Right, for the next example 4.2, we are required to calculate boundary work for a constant pressure process. Okay, the figure here is shown piston cylinder devices which contains of 10 pound of steam and 60 psi and 320 degree Fahrenheit. Heat is now transferred to the system until the temperature reaches 400 degree Fahrenheit. If the piston is not attached to a shaft and its mass is constant, so mass is constant, determine the work done by the system during this process. So we have clue here where the mass is constant. And of course, the pressure is also constant. So how to calculate? Alright, so take a look at, you are required to have a table A6E because it's easier for you to find out the properties of the steam. Alright, let's take a look at what are the parameters that we have. Okay, so we have mass, okay, 100 pound, and we have pressure 60 psia, and we have temperature which is 320 degree Fahrenheit. And then after the process, now you have your T2 is 400 degree Fahrenheit. Okay, so we are required to find boundary work. Okay, so we don't have any other properties or any other information here. So that's why we require table A6E. So table A6E is basically for superheated water. Why? Because in our system we have steam. So steam is superheated water. Remember our we need to draw our PV diagram. Okay, so this is our PV diagram. Okay, so pressure is constant. Okay, so we are starting with P1 and P2. Okay, so let's take a look. Probably this is our P 60 psia, and this is from 1 to 2. Okay. Alright, so in order to calculate work boundary, we are required to calculate area underneath the ground. So basically, this is our WB. Okay, but we need to have V, right? We need to have our volume. Okay, so take a look at this table. First of all, we need to go to the table and we need to find P60 psia. So what is P60 psia? Which is here. So that is 60 psia. And then we take a look at temperature 320 Fahrenheit, which is here. So I already highlighted the value here. So we take volume, okay, volume. So at P1, 60 psia, T1 at 320 degree Fahrenheit. So we have our V1 equal to, okay, where is V1? This is column V1. So this is your value, which is 7.4863 feet cube to pound. Okay, so that is your V1. Okay, since the pressure is constant, so we have to take a look again at the table where P equal to 60 psia, and we need to check for temperature 400 degree Fahrenheit, which is here. Okay, so let's write down here. Okay, so P1 actually is equal to P2, okay? And T2 is 400 degree Fahrenheit. So from the table, we have we have V0 or V2 equal to 8.3548. 8.3548 feet cube over pound. Okay, so you already have V2 and V1. So what you have to do is basically just write down into our equations, into our formula, which is like this. Alright. Okay, so we are given M, right? So because if you take a look at this is feet cube over IBM. So if you want to find work, you need to cancel out the pound. So how to cancel out the point, you need to multiply with mass. Okay, so W equal to mass P dV or mass P V2 minus V1. Okay, so M equal to 10 IBM. Okay, pressure is 60 PSIA and V2 is minus 7.4863 feet cube IBM. Okay. Alright, so you calculate everything and then you will have your value which is equal to 520.92 PSIA dot feet cube. Okay, so you can cancel out IBM here. So finally you have PSIA dot feet cube. You have to convert to BTU. Okay, how to convert BTU? Okay, so this is how you convert. Okay, 1 BTU equal to 5.404 PSI dot feet cube. Okay, so this is already given. So how you want to calculate that? Easy. So you just 1 BTU over 5.404 PSI dot feet cube. So you can cancel out PSI AU dot feet, and then finally you have your answer, which is 69.4 BTU. Okay, so that is your answer. Okay. Alright. So what does it mean? It means that the system used about 96.4 BTU of its energy to do the work, to expand the volume of the steam. So in order to expand the volume inside this piston cylinder, the system use 96.4 BTU of its energy, right? Okay.